Okay, so as we look at Chapter 5, I'm going to go over this formal review with you. It's on page 502. All right, so there's some questions and answers that talk about a review. So I don't usually do this with you, but here's a review for Chapter 7. I want to kind of give this a try, just to kind of make sure everybody's on the same page, and especially with some of our students leaving on a trip here. Okay? You can watch this again if you need to before the test. So on page 502, on the top there that's cut off with this scan is frequently asked questions. Okay, so the first thing that we learned, and the first thing that's sort of really important in this chapter is, what is y equals log of x and y equals natural logarithm of x? How are they similar and how are they different? So I'll direct your attention over here on the left side of the screen and in your textbooks there. There is, in red, is ln of x, and in blue is log of x. So log of x is the logarithm with a base 10. So in our society, we work on base 10, right? The decimal system is base 10. 1 decimal place is the 10th. 2 decimal place is 100. That's 10 to the power of -2. If you have, 15, you have a 1 spot, that's 10 to the 0, and you have a 10 spot, 10 to the 1. So our whole number system is based on the power of 10. And so that's why it's called the common logarithm. You'll see right here, the common logarithm. And this ln, as we explained in this chapter, is really log base e. And that e is a special number, it's a special base that is very useful and easy to work with in calculus. And so we didn't go into too much on why that is, of course, in this course, but that's why e is important. And that's called the natural logarithm, or ln of x. You'll hear me refer to that. Okay? So there are some, obviously, they're very close, okay, in characteristics. They both have one y-intercept at x equals 1, right here. Neither of them have a y-intercept, so these lines kind of come close to the y-axis but never touch it or cross it. The graph extends from 4 to 1, okay, so that's the same for both. The domain is restricted. It's only x values that are greater than 0, so there's no negatives. But the y values, the range, is unrestricted. It can be anything from negative infinity way down here to positive infinity, everything between. Okay? So that's the characteristics of ln and log and what ln and log are. Questions on that before we move on? Okay. The next little bit here is how can we predict the characteristics of a log function from its equation. Okay, that's important as well. We introduced this little letter a right here. So y equals a times log of x, or a ln of x. And so even with an a value, there still is only one x-intercept at x equals 1. So if you recall, that a value stretches the y value, stretches the graph up and down, right? It either squishes it up if a is between 0 and 1, or it stretches it out if it's greater than 1. And then, of course, if it's negative, it flips it around like this. So a negative a value flips it around. And if we look at Desmos here, so this is what we have here, right? So let's put a as, this one is 0. So a here in the book is this parameter right here. And so if we move this parameter around, you can see how it stretches out, right? And then if we bring it in towards 0 here, it squishes it up. And then when it's negative, it flips it around. So that's how that's how that a value, or this value in front here, that's how that affects the graph. Okay, questions, or are you still good? All right. So the other part here is the a value. If it's positive, it's an increasing function, so it goes up from left to right. The graph increases, it gets higher and higher from left to right. And if it's negative, it's called a decreasing function, and it drops down from left to right. Okay? So increasing and decreasing, you'll need to know this. Questions? Also on the side here, you'll notice that it tells you the lesson that you can refer to if you want some more work on that. Okay, so this page right here, talks about regressions. So we've talked a lot about our TI-83 graphing calculator, how to find lines of curves of regression. So that's just a little bit about this as well. And the big thing I want to point out is choosing the variable, which we have talked about. But if you have a table like this, so A and B, and you don't know which one really is X and which one is Y, what you want to do first of all is think about the context of the problem and what it is, what quantity that you're starting with. So if it is, you know, precipitation compared to the month of the year, right? The months are what you're going to start with, and then you're going to measure or take data on the precipitation on that month, right? So you start with January. That'll be month 1. Then you go and you measure the precipitation. So the months then would be the independent variable. That's the X always. Okay? Whichever one responds or is measured based on that is the dependent variable. Okay? Now they also kind of tell you here, if you're trying to build a, if you know that this is a logarithmic sort of relationship, then you can tell that you've got your variables flipped around backwards if you see something like the one on the left here. So on page 503, on the far left, this is not a logarithmic shape. This is an exponential shape. So you've got things mixed up, right? So this would be, you could do a line of regression for this, and you could do an exponential function. That would fit really nicely. But a logarithmic function would not fit nicely at all. So if you flip those variables around, then you have a logarithmic shaped graph. Okay? So that's one of the things that they just talked about here. This is exponential. This is logarithmic. Okay? Yes? Got it? And if you want me to, I can go over the calculator again on how to get the regression functions here. So if we just do this real quick. On your graphing calculators, ignore this. That's calculus logistic function there. But if you go to stat and then over to calculate, so everything starts with stat here. And then you look on this list, and this list has the regression graph shapes. So if you want a logarithmic, here's ln reg. If you want a straight line, here's lin reg. Exponential reg right here. What else? And then sine reg. I don't know if you guys, yeah, you guys have done sine reg, right? But you guys, sinusoidal? No, that's pre-calculus 30. You guys can do that. Okay, so there's your regression shapes and your regression functions there. Okay, and then you select that and you type in your list 1, list 2, or wherever your variables come from, and then vars over here, right? So comma vars over to function equals, and then it'll put the parameters and the equation right into one of your y values on this this right here. Okay. So again, that's on another video. We go over that a little bit more, so you can look at that if you need to. All right. So that's just that's the chapter review that's in the textbook. Other things, yeah, like I say, just modeling with exponential equations was the other thing in there that wasn't in this review, I guess. Okay. So any questions at all about yesterday's assignment, or I guess you really didn't have a yesterday's assignment, did you? So we're going to get right onto the review because I want you all to start the review today. But like I said, I don't think you actually had a 7.5 and 6 assigned, or did I give you one? Okay. So you were just to finish this this example. So I'm going to get you started on the review assignment. I'm going to take a look. If there's not enough practice for this log regression and things from those sections, then I'll assign some extra questions. But right now, your review assignment is the chapter review starting on page 504, and all 11 questions. That's not a lot. And like I say, you might need a little extra practice from 7.3 and 7.5, which we just covered last day. So start the review because I want those of you that are leaving on this trip to be able to do this now, so you can get some questions answered. And then, like I said, you might have some more questions from those sections when you're on. So that's the review.